Hello, ladies and gentlemen. We have lesson 5, vertex form of a parabola today. Okay, so just to add to the twist of more formulas, we have another one we've got to go over. And I mentioned this the first or the second day that we did it was our second lesson, where we started talking about directrix and focus and all that. And I said you were used to the standard form, which is, let me write it, standard form, which is that y equals ax squared plus bx plus c. And you were exposed in Algebra 1 to the vertex form, which is this one right here, okay? And then I introduced you that conic form. So you're going to have 3 formulas of 3 methods of expressing a parabola, either standard, conic, or the vertex form of a quadratic. Okay, so, and you're going to have to know all of them, recognize them, be able to figure out what parts that they show in each formula. So the vertex form is the one we're going to focus on today. So if you remember from Algebra 1, it is y equals a parentheses x minus h squared plus k. Now, these are for quadratics that are x squareds. We haven't seen the vertex form when it's the y squared. So what you're going to see today is all going to be parabolas that are focused on an x squared. So it's either open up or down. You're not going to see any sideways in vertex form. We haven't seen them on the regions, and I don't think that they require them yet. They haven't done anything with them as a vertex in that opening, any that are horizontal and open left, right. So I think for now, this is going to be our focus is all the x squareds for this form. All right, so the vertex is the turning point, which is the h and the k, same as it is for the conic, right? And remember, when you're inside a set of parentheses, you're always opposite. So you see how it says x minus h squared? When it comes out as a positive. And then this one on the outside is always going to be k. Same sign as whatever it is. So if it's in this case in 1, if it's a plus 6, it literally is going to stay a 6. Okay, so use the function y equals 2 parentheses x plus 4 squared plus 6 to complete the following. Okay, so we have to identify the vertex. So you got to be able to recognize, oh, this is vertex form, and this is my h, and this is my k, and this is my a. Not that a really makes a difference right now for us. But when I ask vertex, then when it comes out of the inside the parentheses, you're going to do the opposite sign. So if it's a plus 4, it's a minus 4. And the k just comes down, like I said a minute ago, is just a 6. So that's the vertex. And then use your calculator to graph the parabola. So you can pause it if you want, but I want you to go into y1 in your calculator. Pause if you can't find your calculator. Get your calculator. Plug in this for y1. And like I said before, if you don't have a calculator, you're responsible for yourself here on this. If you don't have a calculator, access like a one that you can graph at home, accessible, then you need to come and see me, and we've got to figure something out. There's some options, but you have to have a calculator for this class. I mean, it's a must. You're not going to be able to do quite a bit of the material if you don't have a calculator, and you got to have one at home. And it can't be your phone. We're not using the phone ones. Okay, so hopefully you put it in. All right, now what I want you to focus on is I want you to go to the table, and I want you to go to -4, 6 is, remember, that vertex, and I want you to look on the numbers that are either side of it. Okay, now because that's the vertex, I can tell for sure that's the vertex because there's symmetry on each side of the y. So these match and these match. Okay, so by putting it in y1, I can see that. When you have it in that conic form, it's not in y1 form, like it's not y equals form. So the conic form you can't use your calculator for. You can for the standard form, right? Because it's y equals. But you can't for the conics, and you can for the vertex form. So we're going to plot some points, and really the only two that only three you can plot are the -5, the -4, and the -3, because the other ones go off the board. 1, 2, 3, 5, 8. Four, 6. And then this one's here. And then we're going to see that the parabola looks like that. So if you remember how to do this from Algebra 1, that's it, right? You just go to the table, make sure that you locate the vertex. The vertex has to be graphed, right? Has to be. You can't just guess on that. And then a couple points on each side if you can do it. Okay, so now what our focus is that I kind of familiarized you with the vertex form is that we're going to do some conversions. We're going to take that vertex form and we're going to convert it to a conics, okay? So, like I said, let's convert to conics form and verify the vertex matches your answer in part A. So here is that formula that we have above. Now, I can look at that and I know that if I want to do it in the conic form, I'm going to write what I expect it to be. Okay, I expect it to be in that form, right? That x plus h squared equals 4p parentheses y minus k. Okay, so we can do that. We can get it there. All right, now I'm going to probably have it switched though, because see how the x plus h squared is on the left side? This one here, it's on the right. Okay, so basically what we're trying to do is we're trying to isolate that right now. Okay, so the first thing I'm going to do is I'm going to minus the 6. Minus the 6. So I got y minus 6. And I'm going to put it in parentheses because I know it's going to be in parentheses here. Follow me? Okay, now I'm almost there. Okay, again, this x plus 4 squared is that, right? X plus h squared, except it has a 2 on the outside. So I got to get rid of the 2. So opposite of multiplying is division, isn't it? And right now that 2 is being multiplied by that x plus 4 squared. So to undo it, I'm going to divide this by 2. The whole thing is going to be, I'm going to divide out by 2. Whatever I do to the right side, I have to do to the left side. Okay? Now, do you notice, remember, I put this in parentheses here, right? It's really that parentheses. I put that in parentheses there. So what's outside of that y minus 6 right now but a 1, isn't it? So if these cancel out, I essentially divide out that 2. I have a 1/2. See the 1 and the 2? That actually creates like a 1/2 that I just kind of pull on the outside. And then I just actually transformed it right there. So let me say this again. When I divide by 2 here, right, it's the same thing as multiplying by a 1/2. Dividing by 2 or multiplying by a 1/2 is the same exact thing. So I actually pulled it, right, divide by 2, and then I created that 1 there, and I just pulled it to the left of that y minus 6. So now it's actually in the same format. It is 4p, right? There's your 4p. There's your y minus k, and then this is your x plus h squared. And that is what I want in the conic form. Okay? We're going to do some more, don't worry. Okay, so the parabola described by the equation. Now that to me, what form is that? It's not conic. It's not standard. That is your vertex form. Has a directrix at y equals -1. Determine the coordinates of the focus of the parabola. Okay, so they're giving it to you in a vertex form, which means I know the vertex. The vertex is, remember, this is your H and this is your K. This comes out as a 2, negative 2 comes out as a 2, 2, right? And then we've got that directrix of y equals negative 1. And just go back to how I had you do it originally. Just do a little sketch. If I need the focus, I've got 2 of the 3 things, right? I have the vertex and I have the directrix. I can find the focus. So graph 2, 2. There's the point 2, 2. And graph the y equals negative 1. And remember, the focus is going to be on the other side of the vertex. So I can tell right now it's like looking like that, right? If I just do a rough sketch, no other points. So the focus has got to be inside here somewhere, right? So I count. I use the p-value. Remember that p-value. I'm going to slow this down just again for you to see. So the p-value, this is negative 1. So I'm going to count negative 1, 0, 1, and 2. So I count up, and I have a p-value that is equal to, this is, we just can't count today, 3. Okay, so I go 1, 2, 3, right? I think I just put 4 there. So. All right, so if I have a p-value of 3, that means on the other side of the vertex, I have to go 3 up from there, and there's my focus, right? Because it's the same distance from the p-value is the distance from the vertex to the directrix, which is also the distance from the vertex to the focus. So I'm going to go p up from there, and my focus then will be 2, 5. Because I'm basically adding 3 to that y value, okay? So focus is 2, 5. All right? So different ways, that the same questions, I'm just using a different form, a different formula for it. Okay, you guys got to give me a minute. I got to blow my nose. My allergies are getting the best of me. Hold on one second. Okay. Thank you for that. Just needed a Kleenex. Now I can think and breathe. All right. So for 3, find the set of points that are equidistant from the point 4, negative 1 in the line y equals negative 5. So if you remember, we already did a problem like this where it says set of points that are equidistant. You're like, what is that? Well, that is a quadratic. They're asking you for a quadratic equation. Okay? Now you have 3 different equations you can pick from. The standard form, the vertex, and the conic. When I hear a point and a line, that line automatically tells me, oh yeah, this is the directrix. And the point is the focus. Because again, I'm going to say it again, the parabola, the whole point of parabolas is for you to come up with all these little points, right? All these little points are the same distance from that focus as it is from that directrix. Although that's a really bad drawing because clearly they're not equidistant. But you get my drift on this. So now it says let's first write the equation in conic form. Well, it makes sense because I have a directrix and I have a focus. So I can't do it in vertex form right off, and I can't do it in standard form right off. So we're going to start with our little sketch like we always do, so you can kind of see it, you can visualize it. And I know some of you are getting to the point where you don't need to do that sketch, but you still need to show me some kind of understanding of it. So make sure that you're doing something. 1, 2, 3, 4. So then on checkpoint, I'm seeing some work here. 1, 2, 3, 4, 5. So I know by seeing this on your paper, I know that you're starting to go, okay, I got to just visualize where, because for the conic, I need the vertex. And it's right smack dab in the middle, right? So there's my V. Okay, and then I'm going to say, all right, that means that I got a p-value, I can see the p-value there, is 2. So I've got p equals 2, and my vertex is 4, negative 3, right? Here's my vertex, which is my h and my k. Now, I can also tell by this picture that, let's do a formal one. So we're going to do 2 more points. So I'm going to go 1, 2, 3, 4 from the focus. 1, 2, 3, 4 from the focus, because it's double the p-value. And I know that that is a quadratic that's going to open upward. So I know I need an x minus h squared equals 4py minus k. And I'm just plugging in what I know now. So I know the h is 4. I know the p is 2, and I'm going to double it, and it's going to be positive because it opens up. And I know the k is 3, so it's going to go in as a positive 3. And there is my conic, okay? Now, what we're going to do is, all right, I got the conic. I got from all that information. That is the set of points, that represents the set of points that's equidistant from a focus and a vertex. I answered that question. Now I want you to try and put it in vertex form. Okay, you got this. Vertex form. This is what you got to have down in your head, okay, guys? I need this in that form. And I told you the only time we're going to ask for vertex form is when it's an x squared problem, right? Which that one is. All right, so I see I got to basically isolate the y. Now what I mean is I'm going to come to the conics and I need that y isolated. I need it all by itself. So, actually, I don't have to do the conversion. Let me do it this way for you, and then I'll do another one later on. So we're going to plug in the vertex. I know the vertex. And the vertex is, I'm going to follow these steps. So I got to have that. Forget the isolate the y. Let me go back. You're going to plug in what you know of that equation, right? So you're going to plug in the vertex first. So I know the vertex is 4, negative 3. Okay, so that's my first piece, right? I need a number for a though, and I can't, by looking at the conic form, I don't know that a value. But I could get another point, so plug in a point other than the vertex and solve for a. Now remember when I graphed it up here? I have a point right there. See that point right there? That point is 0, negative 1, isn't it? 0, negative 1. I can have that as my x and my y here. So I plug it into this equation and I can solve for a. Because remember, the y and the x in any of these forms represents any point that's on the parabola, right? An x and a y in these forms represent any point. So I could put any point in here, and that left side and that right side are equivalent. So it's basically saying this. When x is 0, right, the y value is negative 1. Now, by plugging that in, I see that right now I only have one variable, which is a, and I can solve for that. So, do the math. So negative 4 squared is 16. And then we're going to actually convert that, like we're going to move that around. Do the commutative property. Because a times 16 is 16a. Add 3. That's going to be 2 is equal to 16a. And then divide by 16. A is 1/16. So now I go back, and there is my equation. Now I was going to start to do something where I was going to do something a little different up there for this one. But at this point, we're good. We're just going to leave it. We're going to go with that for now. Oh, Mrs. Reese. I know what I did wrong. Excuse me, because my nose and my stuffiness is getting the best of me today. 2/16 is 1/8. I said that wrong. So I'm double checking on my paper here. Okay, so there's another way to do this, right? So what I did is I did a plug-in. So I plugged in the vertex, I picked a point on the parabola, and then I just wrote the equation, right? I found the A value and just wrote it from there. So once I solve for that A, right, then I know I can just plug it in there. There is another way, which I'm going to show you in a minute, because I'm definitely going to show you another method on how to solve this. But so if I say to you, show that the two equations are equivalent though, to show that this one, right, that conic is equivalent, I can do what I was originally going to pick to do. And that was, I wasn't going to plug in numbers. I was going to solve for y. Remember I started to say up here, I'm going to isolate the y. That's what I'm going to do now. Okay, so watch what I'm going to do. I have to get rid of that multiplying by 8 first. So remember how we did it on the first page. We're going to divide by 8. And remember, I'm going to pull that to side. So see how it's 1/8? It's coming up, right? I can see it. So I got 1/8 x minus 4 squared equals, now I've got y plus 3. Now that y plus 3 is, I can drop the parentheses because there's nothing in front of the parentheses anymore. I got rid of that 8. And then I'm going to minus 3, and look at that. I know that how I solved it above, how I solved it above is correct because they match. I'll be honest, I'm a fan of that second method. I think for me, and I think for a lot of you guys, it's going to be faster just for you to do that. Some of you like me like that, plug in the vertex, plug in a point, and then solve for A, better. But I think many of you are just going to go right to that method, okay? And then you know it's right. So here is a potential question on the read-ins, okay? It really, like I said, really doesn't matter which equation you choose to use because they are all equivalent to each other. But sometimes, depending on the choices in multiple choice questions, it would be wise to choose one form over the other. So when I give you this problem, this is a Regents question, and we've seen it a couple times, where they say a parabola has a focus of 1, 2, and a directrix of y equals -2. The equation of the parabola could be, now look at the answers. That's not conic form, that's actually vertex form. And this is why we go over the vertex, okay? I want you to take a minute, pause the video, and come up with the conic form for this, okay? So pause it, and with a focus of 1, 2, directrix of y equals -2, come up with the conic. Go. Okay, hopefully you have unpaused the video and you've seen me either write it, because I can't pause mine. I wish I could, because I would pause it and write it and then be back on with me. So you have to watch me write it. But so here is the form that I got. Now some of you may have done this. And you put the 0 in, because the vertex was 1, 0, so you may have done that. I don't care, that's fine. But if you do that, remember, that ends up to be actually an 8y. You don't even need the parentheses, it's just 8y. Okay, well that's not bad, because the only thing I have to do to solve for y to get the answers to match is divide by 8, right? And remember, there's a 1 in here. I'm going to pull that 1/8 off to the side. And I'm going to match it, and it's definitely not these. It's right there, number 4. Okay? All right, that is all for today. That was kind of a lengthy one again. The next video that you get from me for sure is not long. It's much shorter. It's average rate of change, so it's fast. It's a review. But make sure that you get these problems done. Do the work for me tonight, today, and then for my A group, this is going to be your last assignment for the 4-day weekend. So enjoy your 4 days, but make sure the assignment gets done, and I'm going to check it on Tuesday when you come in. Okay, so that's for my group A. For group B, you're going to do it after the 4-day weekend. And then, but get it done. You won't have anything over that following weekend, and I will check it when I see you guys again the following week. Okay? All right, take care.